This is going to be a video walkthrough of the Quick Start guide. So everything I'm going to cover in this video is captured in writing at ccoinjoin.com under this Quick Start documentation. I'm going to show how to set up a development environment so that JavaScript developers can run their own CoinJoin experiment and then use that development environment hopefully to build on top of the code that already exists. And potentially, hopefully, integrate their wallet with Collaborative CoinJoin. So first of all, what is CoinJoin? This is the most concise explanation I could give. Basically, a CoinJoin is a special configuration of transaction inputs and outputs that improves your privacy, and this is different than all other Bitcoin type transactions, which typically degrade your privacy. And in order to understand why a CoinJoin is valuable, you really need to understand this concept of UTXOs. If you click this link, it'll take you to Mastering Bitcoin by Andreas Antonopoulos and the section on transaction outputs and inputs. To summarize very quickly, a UTXO is the thing that actually exists. It's the money that actually gets spent. The concept of a Bitcoin is an abstraction. It doesn't really exist. The UTXOs are what represent Bitcoin. So they're the things that actually get spent. And that's the core concept of a UTXO. And then once you understand how these UTXOs and address reuse degrades privacy, you'll start to understand that as you spend UTXOs, your HD wallet will accumulate a lot of these small UTXOs, and they're small in the sense that they have low monetary value, but they have high information content in the sense that that information can be used to de-anonymize you. So what a CoinJoin does is it lets you safely consolidate these small UTXOs into one single large UTXO that has high monetary value but low information content. So then you can go ahead and spend that. It's just like taking the change in your pocket and putting it into a machine and getting dollar bills for it, but doing it in a way that preserves your privacy. So with that recap, let's go ahead and set up our development environments. You're going to need Node.js 16 or higher. I have two computers here, two virtual servers. You can do this on your home computer if you want to run, say, VirtualBox and run a virtual machine. You're going to need two computers. So those can be two physical computers or a virtual computer on your one physical computer, or you can rent two servers in the cloud. That's what I'm doing here. I have two servers in the cloud. So these two tabs are the first server, and they say temp CoinJoin 1. And these two tabs are the second server, and they say temp2 CoinJoin. So they're totally empty. I've got a bash shell on an Ubuntu operating system. I'm running Node 16 and NPM version 8. So let's follow these directions and run a CoinJoin. So the very first step is to clone the HD Cli wallet. This is a command line wallet. I'm going to run this command on both computers, and then I'm going to go into the directory and install the dependencies. And that'll take a minute. Okay, and so with those dependencies installed, we can now create a wallet. And so to get a sense, I'm going to go quickly through this, but to get a sense of the commands available, you can run the help command, which will list all of the available commands. That's actually an out-of-date version. Glad I caught that. That's actually the version that we should be running. Don't worry, I will push these changes up to the master. Okay, so yeah, now we're on the same side. These are the available commands. You can get more help on them if you want to go, say, CoinJoin single --help. Any of these commands will give you a more detailed help. We are going to run the create wallet command. So we're going to give that a name and a description. And actually I want to name this 2 because this is on the second server. There we go. And then I'll run this command verbatim on the first server to create a wallet named test1. So now if I run the list wallets command on both machines, I now have a Bitcoin Cash wallet. One named test2 and the other one named test1. And I can get an address for this wallet to send some Bitcoin Cash to it. And I need to do the same thing for the second wallet. So that's what I'm going to do right now, is send some Bitcoin Cash to both of these wallets. Okay, I have sent about 10 cents worth of Bitcoin Cash to each wallet, and I will now run this update balances command in order to update the wallet and verify that about 80,000 Satoshis that I've sent both of these wallets. So here we can see that the wallet has one UTXO that is approximately 80,000 Satoshis. It's held by this address, and which is generated by our HD wallet with index 1. And again, also on the second wallet, I sent, was it the same amount? Yeah, it's the exact same amount to the second wallet, which is held by its second address. So right now, doing a CoinJoin wouldn't help us at all, because these addresses are anonymous. The Bitcoin Cash came from an anonymous source. We only have one of them. Just participating in CoinJoin just wouldn't give us any value at this point. So what we're going to do is simulate a wallet that has what I call the dust problem, or has a bunch of small UTXOs that have low monetary value and high information content. These would be the change that you get from using your wallet to engage in commerce. And so there is a command called split UTXO, which can be seen here. And that's what we're going to do. We're going to run that command. What it will do is generate 5 UTXOs from the one UTXO that we have. And so that'll give us several lower monetary UTXOs. And so I'll give that a minute to execute. Okay, so I gave the split UTXO command a few minutes to run, and then I ran this, after that completed, I ran this update balances command. And now I can see the wallet has several small UTXOs. It went from that one UTXO of approximately 80,000. This UTXO has just slightly above the dust, about 550. This has about 6,000 Satoshis. This one has about 4,000 Satoshis. This one has 9,000 Satoshis. And this one has about 48,000 Satoshis. And another one here with 9,000 Satoshis. So that's the first wallet. The second wallet now has a few UTXOs as well. It's got this one, 600, 900 sats, 2,700 sats, 66,000 sats, and 7,000, almost 8,000 sats. So that just broke that one UTXO into multiple UTXOs. So now these wallets resemble a wallet that actually needs to use the CoinJoin protocol in order to safely and anonymously combine the UTXOs into one that is of high monetary value and low information content. Okay, so we've got our wallets. I've got a second tab here on the same machine, and again here on that second machine. So the next step is to install the API server, and we can do that with this command. Oops. Wrong tab. There we go. And then same thing, install the npm dependencies. Just following these commands. Once your NPM dependencies are installed, you can start the API server with the start command. And what this is going to do is it's going to spin up an instance of Go IPFS. And so if you don't know what IPFS is, I suggest you read up on it at ipfs.io. It's the Interplanetary File System. It's a peer-to-peer network similar to Bitcoin, but it does not involve blockchains. So we're combining the IPFS network and the Bitcoin Cash blockchain in order to coordinate and create a transaction. And this IPFS network allows each of these two players, and eventually more players, to coordinate without any central point of failure. Okay, so now that the server is running, we can issue the CoinJoin single command, and this will instruct the wallet and the API server to engage in one single CoinJoin transaction, and then stop. And so this will go pretty fast once it gets going. This is the API server, so the wallet has given it its UTXO information and has essentially said, go ahead and start a CoinJoin session. Look for other players that would make good other players to participate, to collaborate and build a CoinJoin transaction. Once they find one another over the IPFS network, they'll exchange UTXO information. One of them will generate an unsigned transaction and pass a copy of it to each player. Each player will sign their inputs, pass it back to the coordinator. The coordinator will compile those into a fully signed transaction and then broadcast it. And I'm going to review that with the flowchart here once it's complete. We're just waiting on it to get started here. The HD wallet here is polling the REST API, just saying, hey, do you have an unsigned transaction for me to sign yet? Every 10 seconds it's polling it. So what we're waiting for right now is just for the two peers. There we go. They just found one another. They're exchanging UTXO information, creating an unsigned transaction, passing it back to the wallet, which signs it and passes it back. And let's see. Partially signed transaction hex. Oh, it looks like there was a problem with the fee. So let's try that again. I'm going to stop the API. I'm glad this happened because this is the point of having a development environment so that we can test things and try things, and it's going to be a buggy place. So let's just start over. Okay, we'll let that spun up, and we'll issue that CoinJoin single command again. What happened in that previous attempt is that the transaction was created, but there's a slight bug at the moment where I'm not leaving enough room for transaction fees. And so it failed because there wasn't enough of a transaction fee to pay the miner to mine the transaction into a block. So there they're off to the races. Both wallets have passed their UTXO information onto the APIs. Now we're just waiting for the two API servers to find one another and initiate the CoinJoin transaction. Okay, there it went through. I'm going to stop these API servers. On one of them, you'll see this line, the coordinator. One of them becomes the coordinator. You'll see this line, CoinJoin transaction broadcast with TXID. So if we take this transaction ID, copy it, and I like to use blockchair.com as a block explorer. If we paste it in there, we can look at the transaction that we generated and broadcasted. And so what you'll see on the outputs is, because we have two players, we have two outputs that are exactly the same in terms of their satoshis, and then one of them had more than the other, and so it got this change output. And in fact, while we're walking through this, I'm just going to update the balances of the wallet, and we can verify some of this information. I made a mistake in the beginning in that I sent the exact same amount to both wallets. I should have sent a different amount to each wallet. So I ended up having to send some from one wallet to the other in order to get this to succeed. Because in real life, it would be extremely rare for two wallets to have exactly the same number of Satoshis. But the important thing here is on the left is all the inputs. So these are all the small, low monetary value, high information UTXOs. On the right are the outputs. So now we have high monetary value, low information content UTXOs. Because there's multiple parties in this transaction and because the outputs are exactly the same, it breaks mathematically any information relationship between inputs and outputs. So a spy company like Chain Analysis cannot associate the outputs to your government identity. And so it makes Bitcoin Cash like cash, fungible and anonymous like cash is. And yeah, so that's the point of the CoinJoin. We succeeded in creating the transaction. If we go back and look at the wallets, we can see here that this wallet on the left in the first server has two UTXOs, one of 58,000 Satoshis, and then some change of 37,000 Satoshis. And the second wallet has a single UTXO of 58,000 Satoshis. So we've successfully CoinJoined our UTXOs in order to consolidate them into an anonymized large UTXO. Now let me walk through this flowchart which describes what we just went through. So on the left is player 1, on the right is player 2. In the middle are their two REST APIs, and the API servers, they talk to one another over IPFS, and then the wallets talk to each of their APIs via a REST API. So I like to refer to this as Web 2, and I like to refer to this as Web 3. And so they each issued this CoinJoin single command, and this flowchart is from the perspective of player 1, because they were the coordinating wallet. They had more Satoshis, so they ended up doing the initiation and then combining the partially signed transactions into a fully signed transaction and then broadcasting it. And so they both passed their UTXO information onto their API with the wallet call. The Peer 2 API server passed its intent to join a CoinJoin, and then Peer 1 saw that, initiated it by saying, hey, do you want to join in a CoinJoin transaction with me? The Player 2 API server responded with the UTXO information. The Player 1 API server combined Player 2's UTXOs with its UTXOs into a CoinJoin transaction that was unsigned, and then passed that unsigned transaction back to Player 2's API, which then passed it back to the wallet, which had been polling the API for an unsigned transaction this whole time every 10 seconds. The wallet got the unsigned transaction, verified it, signed it, and passed the partially signed transaction back to the Player 2 API server, which then passed it back to the coordinating API server, which in this case was Player 1. That Player 1 API server combined the two partially signed transactions into a fully signed transaction and then broadcasted it to the network, and then it was done. And then at the end of that, as part of the cleanup, all players change their IPFS IDs and their Bitcoin Cash addresses and re-enter so that no one can track a player from one session to another. That's also very important, that cleanup. So again, there's more written description here, but I think this video suffices as a walkthrough for the quick start between the written material and the video. Developers should have what they need in order to set up their own development environment. If there is any inconsistency between the video and the written stuff, go with the written stuff, because the written text is much easier and faster to update than the videos are.